electricity and a long history, over 110 years in electricity activities. What is a PV power plant? Large scale, so I just have some examples. We are not quite new in this industry. I can show some projects. And also so that large scale project can also be on roofs. And that's one of the debates we had today. What is large and what is it on roof? Is it large? Yes, it can be very large actually. Okay, so now I'm going to play a little bit about my origin, and my question is, how do we adapt to the UK market? I don't think this is the right trick. Let's think about something else. Okay, we are doing inverters. Let's bring the inverter in the UK. This will not be sufficient. We have to think another way. Okay, so let's define a little bit what is in the PV plant, because we not just do the inverter, we are doing energy management. So the inverter is somewhere in this little box that we are calling PV box, which is doing the transformation between the DC and the AC. That's the purpose. And that's probably the heart and the core of our activity in terms of electricity transformation. But actually, we will be talking also about the array box, which are collecting the electricity nearby the PV modules, and we will have some transformer here. We'll have to bring the electricity to the grid box, and we heard already the grid box and the relationship with the DNOs is not the easiest part for our industry, certainly not in the UK. And of course, for all of that, we heard Nick Boyle talking about asset management. Asset management means monitoring. And you need to monitor everything which is in this field, and you need to do that in an efficient way. And actually heard it's not only about monitor, but it's about controlling. Keep in mind, a PV plant is an asset which is producing cash, but it's still an asset. It's a physical industry, and these have to be managed like a plant, like a production plant. So you have to be able to monitor and control your assets. So in order to select the inverter, actually, you need to take into consideration many parameters, some of them being technical, like performance or reliability, some of them being about their own ability to be able to do what you want them to do. You need to consider the integration into your system. Of course, installation shall be easy to maintain and to service. And then we come up with the bankability, and obviously for you, or for the investors, the return that you can get, and you can cover your risk. Okay, so I think it's going to be technical, and just don't be afraid, it's very simple. The first thing is to think about the inverter efficiency or performance. So we are one of the best performing inverter in the market, which leads in the 98-99% efficiency of conversion of the DC to AC. Actually, the curve is much flatter. This is the reality of the curve from our IEC testing, so from external testing. And in the south of UK, we will basically be using the inverter in this range, so from 20 to 80% of the efficiency window. This, in one way, it's good because it's where you have the highest efficiency, but it's very risky because you are close to this. So we are going to talk how to move this usage in the higher part of the direction. This inverter also includes all the grid management feature, and we've heard again, this is very, very important, and this is going to change in the future. We also want that an inverter has the ability to cope with many changing parameters due to the environment. I mean, a cloud goes over your PV plant, you can't control that, okay? You have to be prepared for that. Multiple MPPTs. You have change of DC voltage due to the degradation of the modules, or the current will degrade, the power will degrade, then the evolution of the best performance of your inverter is going to be affected for the 20 or 25 or 30 years of your efficiency. With regards to flexibility, again, flexibility is when we look at the long term of the inverter. It's not just for now, it's how we're going to be able to cope with the fact that the inverter will be still there in the PV plant in the next years. We just heard from David that the grid is going to change the requirements. So you need to be able to change. And in order to be able to change, you need to make sure that from the day one, the inverter has the capability to cope with future requirements. So you have to have a very large of different voltage inputs, very large window of frequency change, also being able to manage the cost sphere or the reactive current, also need to be able to manage power that the grid might try to inject into your inverter. So how are you going to react to that? And you need to protect yourself. You need to be configurable remotely, and remotely is quite important because this is where you are going to lose all your return on investment if you have to go every time on your site just to do little maintenance and parameters change. I mentioned earlier that we have to use the inverter in its best performance window, and in southern UK, due to climate conditions and due to the position on the Earth, we have to optimize a number of PV modules that you need to fit into the inverter. And obviously, for many reasons, in the UK we will go for higher overpaneling. Overpaneling means you put more DC power that you actually have the MVA from the inverter. It's not one-to-one, of course. And so I just give a few representation of this. The yellow line is an irradiation example. You can see on a sunny day there are some holes in the curve, but basically if you do normal paneling, you don't start very early in the morning, but you will immediately start having the efficiency curve, and then you lose a little bit in the afternoon, but you cover most of your sun, and you have a good efficiency return. If you have a day which have a lot of holes, you can see that even with a perfect paneling match to that curve, you still lose a lot of energy coming in. And therefore, we recommend strongly that you should go for overpaneling with a significant level, because overpaneling will allow you to extend your curve of operation, so you can start collecting electricity earlier in the morning because you oversupply electricity to the inverter. And in the meantime, what you're going to lose in the noon time, where it's really sunny and should be producing most of the electricity, is not going to affect you too much, except on the very few sunny days that you will have without interruption, and you will have more benefits along the year with what you collect on the site here. This is also true not only for sunny days, but also when you come across with the winter days where the full power at noon is not going to make you reach the full power except on very few occasion days. So this is why overpaneling is going to be very important, and it will lead actually, it's getting more and more efficient because the cost of module have been going down a lot. So the impact of putting a little bit more DC cost is going to be recovered in kilowatt hour. The other thing that you have to have in mind is the efficiency curve of an inverter is not totally flat. So we have modeled the situation with the inverters. This is actually losses. You can see the loss going up there. And when you do overpaneling, like plus 20%, you're having some loss, so it's almost flat there. But if you go for very high overpaneling, of course, at 140%, you have a lot of losses that you generate in the inverter. Okay, so this is not exactly what you want. But at the same time, the efficiency of the inverter is going to improve. So if you overuse the inverter, but you use it in a better window for efficiency, you got here the combination of the losses of these two, one benefit and the other one is a challenge, and you find out that you are going into very good condition with very controlled loss when you are in the 130, 140 ratio. So 140% overpaneling is what we will be looking at and deliver more value for your assets. This means that in 1000 volts, the PV blocks, which includes two inverters, are optimized in this type of range. Because when you go to much larger field and you need to bring overpaneling, then you will end up with a lot of cost for your cabling. More modules far away with more current will lead you to buy bigger cables, and that will be very expensive, so you won't be able to optimize this. The other thing is that your module are going to degrade time after time, so if you don't do overpaneling, then you will be underperforming after 5-10 years. Your inverter will not be in the optimized window of operation. So it's very important that you anticipate about this and you calculate among the whole lifetime of your PV plants and anticipate that the module will degrade. Just a quick reminder of what those PV blocks are. Actually, here the array box. You could have an array box with 8, 16, maybe 24 strings connected to them. Then they go to DC combiner and eventually to the inverter. And only there you go to the transformer. So what is important to have everybody to understand is that the grid actually comes till here. So we inject into the grid at this point. Okay? So the inverter is very close to the grid, and the only difference between the grid and the inverter is the transformer, and as you know, a transformer is totally static. So whatever problem there is on the grid, it will be fed back into the inverter, and so the inverter is the first active element in contact with the grid. So the inverter is very key into your grid connection. Now, if we look at the whole PV plant, for all your PV boxes that go there, they are connected, in this case, in a star model, to the main switch gear, to the grid box, and so you have the feeders and then you have the security. So what is important to see is that here you can disconnect from the grid, so your grid operator is going to cut you here, but is not going to interfere with your PV box. So in terms of relationship with your grid operator, is going to cut you here, or actually to supply you some electricity or for the grid, or to take your electricity from here. But actually, your intelligent part is inside these PV boxes next to the inverter. And therefore, the integration of the whole system is very, very critical, because everything is linked together. I just give an example of what the impact of working with, for example, a 4 megawatt ampere block would be if you use the 1.3 megawatt ampere PV box that I just mentioned, and you actually do this 1.4 over paneling, so you are able to generate here 4 megawatt ampere. And if you compare this to standard PV boxes, which are running with 2 megawatt ampere and they don't do the over paneling in such a ratio because the inverter cannot cope with it, then you can see that the total energy harvesting is getting much bigger, because you got several opportunity for improvement. You work with a better window, you will have more source of energy, you will have more activities, so everything all around is going to bring you a lower LCOE. So that's a very important point in the fact that you integrate the electrical scope by understanding absolutely the capability of the inverter. I mentioned earlier, everything is integrated in one solution, so if we start from the DC, you can actually include the power switch, you can include the array box, you can see here array box with full monitoring capability, and the DC combiner box, which will collect all the array box before the inverter. And then when you go to the medium voltage, you of course have the transformer, metering, circuit breaker, and also the protection relay. Protection relay, actually, it's a good point, because this is something that we expect grid operator to change requirement. So this is how they will decide to disconnect you or not under certain grid conditions. Right now, they are trying to tighten their operation mode into windows where it was not really well controlled so far. And because of the development of the renewables, we will see more and more requirement towards protection relay. And of course, switchgear that have to be approved by the DNOs. So this is very key for us. And so far, we have been participating, involved in on the connection of many, many projects because of this capability of the medium voltage. So it's not just about inverter, but it's a full capability. Other products that I've shown and mentioned are following a very, very robust industrial process for development, and specifically in terms of reliability and in terms of testing. So we are delivering, okay, I'm going to do it. You close your here and you don't repeat anywhere, but we have actually closed the deals in Japan. That means our inverter are able to cope with vibration, are able to cope with all the local conditions, and this is, as you know, a quite tough market to enter into. And this is because we have this very strict development of product of all of our projects in electricity management, in energy management, that we can do that. We also have some in environment that are much more high temperature in Middle East or now going to South Africa and so on. So we have the product that can adapt to all of these environments. We've talked about asset management, and this is where we come to sensors, capability to monitor every part of your asset, to be able to check everything's going on, but not only to monitor, but to control. Otherwise, what the value to know that your stuff is going bad when you don't know why it's going bad and how to repair, how to fix it. So this is one message which is very important to us, is monitoring is not enough. Monitoring is good when you do residential business, because actually you switch the string inverter and you replace by another one and off we go. But this is not the case. We are talking about large utility scale investment where you have the bankers and the debt financing that they want to cover their ass. So this is about bankability. How do you control in the long run? And for this, the best is not only to have the right sensors, but also to be able to manage the data. So you need a strong data management system, and then you need to be able to extract from this data some intelligent information. And for this, obviously, the SCADA is what you need, that we have from the industrial experience for automation and PLC. So this is how we have taken the approach for monitoring and control. This is a plant, this is actually a factory that produces cash, electricity. You need to control it in detail. And you must be under your control of your investment. And what we're offering is not only monitoring or control on one PV plant, but we also offer the hypervision. So you want to be able to control multiple plants and compare them in terms of quality. And in order to be sure that they are maintained in the right condition in the long run, you need to have the right supply chain for the spare parts, the expert to be able to do the service for the top level service. And actually, when we talk about spare parts, something I haven't heard so far, but I think it's very key to mention as part of the bankability, is that you need to be able to have the spare parts in 20 years. So who is going to give you security that your inverter will be able to be repaired in 15 years? Only bankable company that will be able to sustain and to maintain and continue availability of the spare parts. So that's an important part of our message. Now, in the UK, we have participated to several projects, over 100 projects. I mentioned 80 in terms of a connection to the grid, but also we have 17 megawatts of inverter. So that's basically a summary of my talk. Cost is very, very critical for everybody. Of course, energy harvesting is going to make the return. The ability to perform maintenance and maintain the system in good condition, and of course the protection of your assets. So we are, again, all of this is related to your bankability. So I wanted to show this beautiful picture and say thank you to Vogt and Anton. We have done several projects with Vogt in the UK, and I think they are very, very well designed and constructed, and they have selected China to do that. So I want to take the opportunity.